All right, now simplifying radicals is an important key to a lot of the things we study in Chapter 8 on right triangles. So I'm going to give you a few examples of simplifying radicals into a simpler radical form. That doesn't mean a decimal, that just means a simpler form that still has a radical in it. Now our goal for simplifying radicals has to do with the square roots of perfect squares. Like the square root of 4 is 2, the square root of 9 is 3, the square root of 25 is 5, square root of 100 is 10. You get the idea. So when we have the square root of a perfect square, it gets pretty easy for us to simplify it. So we're looking for perfect squares as we are simplifying. So I will take 12 and make a factor tree with it. 12 is, let's see here, 3 times 4, and 4 is 2 times 2. Now, whichever factors you choose, you should still get 3, 2, and 2. So the square root of 12 is equal to the square root of 2 times 2 times 3. Now, since I have a pair here, the 2 and the 2, it gives me a perfect square. So I'm going to write this as 4 times 3. Now, if I have the square root of two things being multiplied, I can separate those into two separate square roots. Okay? And the square root of 4 I know to be 2, and the square root of 3 is still the square root of 3, and so this becomes, simplifies to be 2 square root of 3. Okay? Now, in practice, I don't usually go through all these steps because it takes too long. In practice, I do my factor tree, I find my pair. Now, when I have a pair, that means I have a perfect square. And for that pair, I take one of those numbers and write them outside of my square root, and then whatever's left without a pair, without a perfect square, stays inside. So by 2, my pair of 2's, I have a 2 here, and the 3, I have a square root of 3. So we just jump from here to here. Let me give you an example of that. The square root of 90, now 90, I'll just pick 3 and 30. 30 is 3 and 10. 10 is 2 and 5. So I have a pair of 3 and 3. That means I have a perfect square. So I rewrite this as 3 from my pair of 3's, square root of what's left, 2 times 5. And 2 times 5 is 10, and so 3 root 10 is a simplified form of the square root of 90. A few more examples. Multiplying the numbers and express your answers in simplest radical form. 9 times root 2 is simply 9 times root 2. Okay, the reason that's important to me is the fact that if you write 9 root 2, what's in between them is really a multiplication. We just don't write it. Okay, so 7 root 2 times root 2. Now I can combine these two together to be 7 times the square root of 2 times 2, which is 7 times the square root of 4. And the square root of 4 is 2, which is 14. So this is actually equal to 14. Okay, so this, a little more complicated. 3 times 2 is 6, and the square root of 3 times the square root of 3 is the square root of 9. Okay, and the square root of 9 I know is 3, so 6 times 3 is equal to 18. Okay, now this next one's a little more complicated. 6 times root 2 is 6 root 2. And the square root of 2 times the square root of 2 is the square root of 4. Okay, I'll rewrite that down here. 6 root 2 over the square root of 4. Now, the square root of 4 is equal to 2. Oh, now 6 over 2 simplifies to be 3 over 1, and I got 3 root 2, which is a simpler form. Okay, a few more examples, just the same thing. 45, factor tree. I'll pick 9 and 5. 9 is 3 and 3. Okay, so I have a perfect square of 3. 3 from that pair, root of what's left. 700. 700, I get 7 and 100. 100, I get 10 and 10. 5 and 2. 5 and 2. I have a pair of 5s, a pair of 2s, and the square root of what's left. So 5 times 2 is 10, square root of 7. Okay, 540. let's see here, 540 is 54 and 10. 10's 5 and 2. 54 is 8 times 7, and 8 is 4 and 2, and 4 is 2 and 2. So I have a pair here and a pair here. So from the first pair of 2's, the second pair of 2's, square root of 5 times 7, and so I get 4 times the square root of 35. Okay, just a few more examples of this kind. Now, mathematicians don't like having a square root in the denominator. So the way we simplify here is by multiply by the top and bottom by the square root of whatever's down here. So here it's root 5 over the square root of 5. Let me kind of move these over so I have a little more room. Okay, so up here I get 10 times root 5 is 10 root 5. Root 5 times root 5 is the root 25, which 10 root 5 over, let's see here, root 25 is 5. Simplify this down to be 2, and I get 2 root 5, which I think you'd agree that this is simpler than 10 over root 5, which we started with. Okay, this one again, we simplify this by multiplying top and bottom by what the denominator is, root 2. The top I get 7 root 2. The bottom I get the square root of 2 times 2, which is 4. And the square root of 4 is 2. Now 7 over 2 doesn't cancel, so I'll just leave it like that. Last problem. Again, I simplify by multiplying top and bottom by what the denominator is, by root 3 over root 3. 5 times root 3 is 5 root 3. Root 3 times root 3 is root 9. And the square root of 9 simplifies to be 3. And that doesn't simplify anymore, so I'll just leave it like that.